Hello, everybody. This is Ahmed, your favorite physics tutor. And today we're going to talk about physical quantities. Physical quantities. It's an important topic and it's one of the very first topics in IGCSE. That's why I believe you should, or you must actually understand it intuitively because it's the foundation in physics, okay? So today it's not gonna help you to go through papers or exams or anything like that. I just want you to understand it intuitively, okay? That's the point of this lesson. So, physical quantities are ways to describe situations, events, or objects in physics, okay? So, for example, this is a pen. I just bought it, okay? Maybe I bought it, maybe in the morning. Okay, so I bought it in the morning. I'm describing this event. Okay, when I bought it, it was in the morning. It's that big, you know, it's that big or that long, the pen. Okay, so I'm describing the object, the distance or the length. Okay, I can even use it to describe the diameter, okay, of the pen, right? I can say that this pen is, maybe it's not that heavy. It's as heavy as a normal pen, a usual pen. So here I'm using the mass. Maybe it's been in my pocket for a while now, so it could be warm also, right? Describing the temperature, it could be warm. Maybe it's a bottle of water, so we can say, we can talk about the volume of it, can talk about the speed of the car, the force, that something can take before it breaks, many things. But this is just like a very basic example, the pen, okay? But also notice that all these physical quantities or physical quantities in general, we can measure them, okay? They are measurable. So when I said the length or the size of the pen, I told you it's that big. Okay, so you can know now how big it is because you can see my face just behind it. So you can compare it to my face. Okay, that's basically what measurement is. So in measuring, when you say something is 20 centimeter maybe long, you're saying that it's 20 times as centimeter. It's 20 of these units. You know what a centimeter is, of course, and you just like you tell me you're telling me I just like multiply the centimeter in your mind, multiply the centimeter 20 times, and this is the length of it. Okay, so you're basically comparing the object that you have to a unit that you know how big it is, how heavy it is, how hot it is, how long it is, maybe it's time, the second. Okay, so it's basically comparing the object or the property of this object, maybe it's distance, time, mass, whatever, to a unit that you know, okay, very well, that you have a grasp on in your mind. Okay, so that's the meaning of a physical quantity. So a physical quantity is a property of an object, properties of objects that can be measured, measurable. The time, such as mass, such as temperature, volume, speed, force, these are all physical quantities that can be measured. Okay, physical quantities can be measured in general. Okay. Now, when you measure a physical quantity, as I told you, it's basically you making or doing a comparison. Okay, you're comparing it to something else. So measurement is knowing how big, how fast, how long, whatever the property that you're measuring, how this property, how much of this property exists. Okay, that's the meaning of the measurement. And here, for example, when you hear that a battery size is AA or D or C, maybe you don't know what that is, okay? Because maybe you haven't seen an AA battery before, right? So to just like give you an idea of how big an AA battery is, you can compare the size of it to something that you already know, which is a matchstick, for example, or this stick, small stick. It's a matchstick, I guess. Maybe some coins, okay? And there is also a ruler here, a very far right. In this way, you can have an idea of what an AA battery looks like. Okay, now when I tell you that I have an AA battery, you know how big it is because you could compare it. You compared it to something else that you know how big it is, okay, which in this case, the coins or the matchstick. The pen that I have is that large, okay. I was saying that. I said it was warm because it's been in my bucket for the entire day, maybe. It's not that heavy. It's as heavy as other pens too. I bought it in this morning, okay, this morning, okay. Maybe other people would use things like handful of, maybe, handful of coins or handful of food. Some people use ounces, all sorts of units, okay? They're using all different kinds of units. Foot, inches. So there's so many units in the world, but that could be a problem, okay? Because we want to advance science. We want to experiment and we want to standardize science, okay? So in order to do this, we need to have standardized units. So when you say something is 20, ounces, 20, let's say 20 grams or 20 ounces or 20 stones, whatever, 20 pounds, whatever the units that you're using. We want to standardize it. We want to have a unit that we can use, all scientists can use, all engineers can use. It's standardized. So that's what, standardized units are. So instead of having all these units, for example, for mass, instead of saying ounces, stones, pounds, instead of doing all this or using all these units, we need to have only one unit that we can use, all scientists can use, all engineers can use. So somebody came and said, okay, forget about all these units. I have something else. This is called a kilogram. I just made it and it's called a kilogram. Okay? This is the kilogram. And even the kilogram, it also has a definition, okay? But we're not going to talk about this right now. But also the kilogram has a definition. But this is the standardized unit, all right? If you want to measure something, you can measure it using this one, okay? You can measure it using the kilogram to measure the mass. And now, for other standardized units, okay, or other units, and maybe the most common units here we're going to talk about. So, for example, the distance, let's say something is 20 meters long, okay? 20 meters long. Or something, okay, took 4 seconds to happen, okay? So as you can see, I'm describing the objects, I'm describing the events, or something is 4 kilogram, or the temperature is 30 degrees Celsius, or you can use Kelvin, okay? But let's say it's 30 degrees Celsius, okay? This is not the standardized one, but it's okay, Celsius. Maybe something is, or the bottle of water is 1 liter, okay? Or 2 gallons, only liter here, or cubic meter. The speed might be 25 meters per second. Maybe the force is 20 newtons, okay? Maybe the weight is also, maybe let's say 100 Newton, okay? So these are called the units. As I told you, you are measuring the object or the event or the property relative to something that you know. That's the unit. We're comparing it to something that you know. All right? So you know what a kilogram is. Okay, it's 4 times the kilogram. 4 times the bag of potato that I bought yesterday. Because you know what a kilogram is. You know what a kilogram is? You're comparing it to this one. Okay. You know what a second is. You're comparing it to the second. You know what a meter is. You're comparing it to meters. 20 times the meter. All right. So now the question is, do you think this is always like this way? It's the full description, okay? When you say something is 20 meters away, is this the full description? Do you understand where this thing fully? Okay, so that's the question. When you say something happened 4 seconds ago, do you understand this fully? Okay, I have to only these two right now. So something is 20 meters away. Okay, something happened 4 seconds ago. 4 seconds ago. So in the first one, 20 meter away could be this here, like 20 meter. I'm here, okay? This is where we are. So it could be in this direction. Maybe this thing is here, or maybe it's here, or maybe it's here, or maybe it's here. Okay? So you can't describe where something is or the distance only using the magnitude. This is the magnitude. You still need a direction to describe it, to know fully what you're talking about. So we need a direction here alongside the magnitude. So we need both the magnitude and the direction. In this case, we call this the vector quantity. This is called a vector. In this case, 4 seconds ago. So you don't need a direction in this case. All right, so you don't need a direction. This is called a scalar quantity. So you have two types of quantities, a scalar quantity and a vector quantity. In a vector quantity, you still need a direction to know what I am talking about. In a scalar quantity, you don't need to know the direction. It doesn't have a direction. Okay, so mass, scalar, temperature, scalar, volume, scalar, speed. What do you think? Okay, the car is moving at 20 or 80 kilometers per hour. Okay, so the car is moving at 80 kilometers per hour. What do you think? Okay, which direction? So this one is vector quantity, right? It's a vector quantity. Force. Are you pushing this way, this way, this way? So vector quantity still. So now we're going to talk about 3 properties that are very, very confusing. Force, mass, and weight. So what's the difference between the 3? All right, so let's start with force. Okay, force. I'm not starting with mass, I'm not starting with weight, I'm starting with force. What does a force mean? Force basically means a push or pull. Push or pull. If you pull something, okay, that's a force. If you push something, it's a force. Okay, can you think of other examples of force? Can you do this? Yeah, maybe gravity force, right? Gravity force. Yeah. So why is this a force? Because, for example, this phone, once I leave it, it just falls. Okay. The Earth is pulling it downwards. Okay. So this is a type of force, gravity force. Something is pulled, or two objects are pulling one another because they have mass. But let's just put this aside right now. Okay, so this is gravity force. All right, force, gravity force. Okay, so we have force, we have some sort of force called the gravity force. Force are measured, or force is measured in Newton. Also, we will leave this aside for now. So it's measured in Newton. Okay, as I told you, you need to know what a Newton is. in order for you to know what somebody is talking about when they say something like 100 Newton, okay? You need to know what the unit looks like or feels like. That's the meaning of force. That's the meaning of gravity force. So gravity force, another way to say it is weight. But that's a specific type of gravity force. If you have two objects, okay, that's the first object, let's call it the Earth, and you have another object which is here. Maybe it's very close to Earth, very, very close to Earth. It's here, okay, and it's very, very tiny. They are pulling one another, okay, so this object is pulling the Earth towards it, and the Earth is pulling this object towards the Earth. And in this case, this is gravity force, but we say that this object has weight. This tiny object, it has weight. Like you, like me, like anything on Earth. We all have weights because the Earth, basically, it's very massive, much, much larger than us, and it's pulling us towards it, okay? So that's weight. So we have the idea of force, and this is pull or push. You have one type of force is called gravity force, and a type of gravity force, or a specific type of gravity force, it's called the weight, okay? The weight of an object on Earth, maybe it's on the moon, it's on another planet, whatever. So that's the meaning of a weight. So if this object is here, very, very far from Earth, very, very far from other stuff, okay? In this case, weight, which is gravity force in this case, it's almost zero. If you put this object that we have here, on another planet that is less massive than Earth, the weight will be smaller, okay? It's not as big as Earth, so the weight will be smaller. If it's on a bigger planet, the weight will be bigger in this case. But in all these situations, it's the same object, okay? The same amount of iron, the same body, the same amount of wood, the same amount of water, the same amount of something. The amount of something, this is another kind of physical quantity. It's called a mass, the mass. Okay, so mass is how much of the matter you're talking about in this object. So the mass of a piece of iron is 5 kilograms. That's the amount of iron in it, 5 kilograms. And it doesn't matter whether it's away from Earth, on a spaceship, somewhere interstellar, or on Earth, or on another planet, it's still 5 kilograms. But the weight, how much the planet is pulling it towards it, this one differs, okay? It's different. On Earth, it's a value that is different than the value here on the moon, or on Mars, or on Saturn, whatever. It could be zero, okay? It could be zero in the deep space. Okay, so that's the difference between mass, weight, and force. Okay, that's the end of our video. I hope you liked it. If you did, please don't forget to like it and leave a comment, subscribe to our channel, and see you next time. Thank you.